So let's start with the 15th example. What is said here? A satellite of mass m is launched vertically up with initial velocity u from the surface of Earth. So that's the surface of Earth, and a satellite of mass m is launched with velocity u from the surface of Earth. Okay, so that's the velocity u with which it is being launched, u meter per second. After it reaches height equal to radius of the Earth, so when it reaches here at a height r, it ejects a rocket of m by 10 so that subsequently a satellite moves in circular orbit. The kinetic energy of the rocket is, so first of all we should find the velocity of the satellite plus rocket is how much at this position by conservation of energy. So in that case I can say the total energy on the surface of Earth is equal to total energy at the height. Total energy on the surface of Earth is minus g mm upon r plus half m u square is equal to, at a height it would be minus g mm upon r plus r will be 2r plus half m v square. So this minus will come here, so it will be minus gmm by 2r plus half m u square is equal to half m v square. M get cancelled, half will get cancelled from all side. So the velocity of the complete system at this height of just achieving this height would be u square minus root gm by r in the vertical direction. Okay, now what is said here at this point, so I will draw here. Here it is said that when the rocket and the satellite system is here, then in that case what is happening, it ejects a rocket of mass m by 10 so subsequently. So this is the condition before collision. While just after the collision what is happening is, in order to eject the rocket, because the satellite want to move in circular orbit, the velocity taken by the satellite should be tangential. So this is the tangential velocity taken by the satellite. If m by 10 is the rocket or mass of rocket, then obviously 9m by 10 will be the mass of satellite, and this is the remaining rocket which moves tangentially here, and this velocity. Satellite will all purely have this velocity. Okay. Now the conservation of that can be done by conservation of momentum. We need to find the kinetic energy of rocket. So first of all, the momentum along x direction. So total momentum in x direction initial must be equal to total momentum in x direction final. Initially along x direction or vertical direction there is no momentum. So 9m into 10 into velocity of satellite plus m by 10 into velocity of the rocket, which we need to find. As they said, the satellite is moving in a circular orbit, then obviously the velocity achieved by the satellite is the critical velocity, and critical velocity is given by under root gm by radius of orbit, which is 2r from the center of Earth, plus m by 10 into vr. So the velocity of the rocket would be, so this will come on this side, that becomes minus 9m by 10 under root gm upon 2r is equal to m by 10 into velocity of rocket. So m by 10 and m by 10 will get cancelled out, and the velocity of rocket, the negative sign indicates only that the rocket is having a velocity tangential, which is given by this thing 9 under root gm upon 2r, while the rocket is also having this kind of velocity here. Again, by conservation of momentum along y direction, we can find that velocity, that is velocity of rocket, this one. Okay, so let's take the next slide. Now, the total momentum in y direction initial must be equal to the total momentum in a y direction final. The initial momentum in y direction is complete m mass is having velocity v, which is being calculated initially there, and in y direction the mass of the rocket is m by 10 into the velocity of the rocket, and satellite is not having any velocity because it is being launched in the orbit, so it is having tangential velocity. So this m and this m cancel, so velocity of rocket in the upward direction would be 10 times of this value, which is this u square under root this thing. So it will be under root u square minus gm by r. Now, as we know, as rocket is having both two velocities, one in the along x direction and one is along y direction. So in order to find kinetic energy, the net velocity of the rocket would be velocity of rocket in tangential direction square plus velocity of direction in the vertical direction square. So this will be 100 in bracket u square minus gm by r plus 81 into gm by 2r. So this 100 will go inside, it will be 100 u square minus 100 gm by r plus 81 gm upon 2r. So it will be 100 u square. For getting this 2 here, multiply and divide by 2. So it will be 200 gm upon 2r plus 81 gm upon 2r. So the velocity of the rocket is 100 u square minus, so 200 minus 81. So what would be the result for 200 minus 81? So 10 minus 1 will be 9 and 9 minus 8 will be 1, and this will be 119 gm upon 2r. The kinetic energy of rocket would be half mv square, so it will be half m by 10 into v square, and as this is v square only, so it will be m by 20 in bracket 100 u square minus 119 gm upon 2r. So let's say which is the correct answer here. Okay, so kinetic energy of rocket is being we need to find, and here as 119 is present in option D, so hopefully that would be the correct answer. We need little adjustment here to do this. So m, this 20 will go inside, so it will be 100 by 20 u square minus 119 gm upon 40. So 21s are 25s are, so it will be m in bracket 5 u square minus 119 gm by 40. Thank you.